Hello students, today I will take the remaining part of Neet 2019, the paper series H1. Now I have the question number from 38 to 45. In each section of biochemistry and physics, there are 45 questions. So I take the question number 38 to 45. To 45. Now question number 38. Now 38, this is given that in a young double slit experiment, double slit experiment, if there is no initial phase difference, if there is no initial phase difference between the light from the two slits, between the light from two slits, a point on the screen corresponding to a point on the screen corresponding to the fifth minimum, has path difference, Number 1, 11 lambda by 2. Second option is 5 lambda by 2. Third option is 10 lambda by 2. And fourth is 9 lambda by 2. Now the solution. There is no initial phase difference, so we have to take the fifth minimum. So for minimum, the path difference delta equal to 2n minus 1 into lambda by 2, where n equal to 1, 2, 3, 4 and so on. So it is asking the fifth. So we will keep n equal to 5. So for n equal to 5, fifth minimum, this is giving fifth minimum. The delta is equal to 2 into 5 minus 1 into lambda y. 10 minus 1, so this is now your 9 lambda y. This is the answer. So the answer is fourth. Correct choice is fourth one. And now question number 39. So in 38 there is the direct application of the path difference of the fringes. 49 in double convex lens, a double convex lens, a double convex lens has focal length focal length 25 centimeter. The radius of curvature of one of the surface, the radius of curvature of one of the surfaces is double of the other, is double of the other. Find the radii if the refractive index find the radii if refractive index of the material of lens is 1.5, and our answers are here. The first option is 50 centimeter and 100 centimeter. The second option is 100 centimeter and 50 centimeter. Third option is 25 and 50, 25 centimeter and 50 centimeter. And fourth is 18.75 centimeter and 37.5 centimeter. Now the solution. We are given that the radius of curvature of one of the surface is double of the other, and you are given the focal length 25 centimeter. Refractive index is to be 1.5. So we have the formula 1 upon f equal to mu minus 1 into 1 upon r1 minus 1 upon r2. Here the given is that f equal to 25 centimeter, r2 equal to 2r1, and mu is equal to 1.5. You have to find the R1 and R2. So this is 1 upon 25 equal to 1.5 minus 1 into 1 upon R1 minus, so this will be plus 1 upon 2R1. Plus is why? Because the second radius of curvature is always negative. So negative and negative will make it positive. So this is 1 upon 25, 0.5 into 3 R1 upon 2 R1. So this is 3 upon 2 R1. 3 upon 2 R1. Or R1 equal to 25 into 0.5 into 3 and divided by 2. So this you can take it to be 10, 5 to the 2. This is your 75. 75 upon 4, 4, 1, and this is now your 3, 7, 35. 4 8 is 32, and then 3, then this is now your 75. This is R1. This is the value of R1. Then you find this R2. This is not just double of it. So R2 equal to 2R1. So 2 into 18.75. This is your 0, 14 and 15 and 36, and this is now your 37. So much centimeter. So R2 is 37.5 and this R1 is 18.75. So our right option is 4th. So our answer is 4th. So this we have to keep in mind that the radius of curvature of the second surface is always negative. So because of that, then this minus sign will be the positive one, and then you just calculate it and find the value of R1 and R2. So this is the direct application of the formula. So this is the lens maker formula. This is called lens maker formula. And now question number 40. Two bullets are fired horizontally. Two bullets are fired horizontally and simultaneously towards each other. And simultaneously towards each other from the rooftop of two buildings buildings 100 meter apart. 100 meter. Apart. And of same height. same height of 200 meter. 200 meter with same velocity. Same velocity of 2.5 of 25 meter per second. When and where? When and where? Where will the two bullets? Will the two bullets collide? Now here this G is 10 meter per second square. This is given. Now the options are, first option is they will not collide. They will not collide. Second, after 2 seconds, at a height of 180, at a height of 180 meter. And third option is after 2 seconds, at a height of 200 meter. At a height of 200, no, this is not 20 meter. 20 meter. And now fourth option is after 4 seconds. After 4 seconds at a height of 120 meter. At a height of 120 meter. This is given. So what that there are the two bullets which are fired simultaneously horizontally towards each other from the two buildings, each of height 100 meter, height of 200 meter and apart 100 meter, and the bullets have the same velocity, initial velocity. This is 25 meter per second. So now I take that suppose this is a building. This is a building. This is now ground floor. Now these are your 100 meter apart. And the bullet is fired from the rooftop. So from here the bullet is fired. And because of gravity they will fall down. So they will follow a trajectory, that is projectile trajectory, like this. And let they collide at this point. And this point, this distance is x. This distance is x. Now you are given that they are moving with the same velocity 25 meter per second. 25 meter per second. It means that the horizontal velocities are given, but there is no vertical velocity at all. So when they will fall towards the ground, then this is because of the gravity. So they will follow this trajectory like this, in this way. Now this is the point where the two bullets collide with each other. let time to collide is equal to t, and the height that they fall. Now this height is given 200 meter. This is 200 meter. This is also 200 meter. Then this will remain the height at which they will collide from this one. This is now your h minus x. This is also h minus x. So they are horizontal, then you find the this distance, this to this one, and let this distance is now x1, this distance is x2. So sum of these two will be 100 meter. So what we have, that this horizontal range is x1. This horizontal range is x, then this is now your 100 minus x. So much is, so horizontal range. Horizontal range. This is suppose point A, this is now your B. Horizontal range for bullet A equal to x, and horizontal range for bullet B equal to 100 minus x. Now we have taken the time t where they collide. So you just find that this x equal to this is your x, horizontal range equal to the velocity into the time. So velocity is 25 and time is t. And for second this is equal to 100 minus x equal to, this is now your 25, and time is again the t into t. So both ranges are equal. So this gives you what? That this x equal to 50 meter. So this means that the horizontal range of each of the bullet is 100 meter. So this horizontal range is the same. If suppose this horizontal range would have not be equal to the 100, then they will not collide with each other. Now we find this vertical height x that is given here. This is now, this is you take, this is now your y. This is now y. So vertical height. Vertical height for bullet. Now if you keep the value of x here in either of these equations, then you can find that this t is equal to 2 seconds. It means that both the bullets will collide after 2 seconds. Vertical height for each bullet this is now vertical distance of falling the bullets is equal to y. So now take now in vertical direction there is no initial velocity. So you have this y is equal to, we apply the second formula. So this 0 into t, this is now your 2 plus half g into 10, this is now your 2 square. So in vertical direction, velocity initial velocity. This is equal to 0. This is why we have taken it to be now here 0. So this y is equal to, this is now your 1 by 2 into 10, and this is now your 4, this 2, so this is y equal to 20 meter. It means that in 2 seconds they will fall a distance of 20 meter from the top roof of each of the building. So now height from the ground is how much? This will subtract the 20 from 200 meters. So that will come out to be 180 meters. So vertical height. Vertical height of each bullet is equal to 200 minus 20 equal to 180 meter. So this is now 180 meter. So much is 180 meter. So it means that they will collide after 2 seconds and the vertical height will be 200 meters. So our answers must be equal to what? After 2 seconds at a height of 180 meter. The correct choice is second. So one answer is second. So this is the case of projectile. And just remember that in case of projectile we have the horizontal and vertical velocities. This equation is applied for the vertical height. If there is velocity in the vertical direction, then you use the velocity. Since this is given the horizontal velocity, so we have used it in the horizontal range. X equal to velocity into the time. Here also this equal to velocity into the time. Then we have taken it. And remember that they will not collide if the sum of these ranges, horizontal ranges, is not equal to 100 meter. Now we have the question number 41. The stress strain curves are drawn. The stress strain curves are drawn for two different materials. Two different materials, X and Y. X and Y. It is observed that the ultimate strength points and the fracture point are close to each other, for material X material X and but are far apart, but are far apart, far apart for material Y. For material Y. We can say that material X we can say that material X and Y are likely to be respectively Now your first choice is plastic and ductile. Plastic and ductile. Second, ductile and brittle. Ductile and brittle. Third option is brittle and ductile. Brittle and ductile. And fourth is brittle and plastic. Brittle and plastic. Now we have the solution. We have the strain stress curve. Here this is now stress. This is strain. This is strain. And this is the wire A, this is now wire, this is X and this is your Y. Now here is given this is now point 0, this is now A, this is now your B, this is C and this is now point D. Then this will continue. This is now point E. This is similarly A, here is B, here is C and then here the D and then this goes up to this. This is suppose point E. So these are the two stress and strain curves. So what is given in question that we have to read it again so that we could understand. Strain for the two different material X and Y, it is observed that the ultimate strength point and the fracture point. So this is a fracture point. E, this is fracture point. This is X, this is Y. This is the fracture point E and D. D is the ultimate point that we are given this ultimate strength point. Ultimate strength point. So for this is what we are given here, that for X the ultimate strength point, this is now D and the fracture point E are close, so they are near to each other. Here the ultimate strength point and the fracture point, this is now E, they are far apart. So now you can see from here that since these are very close to each other, so we can say that this material X is brittle, because this will break down after this will break after this point E. As the stress is increased slightly, this will break at the point E, because this is the last is given the fracture point, and here fracture point is very large, is away from this the ultimate strength point. So this means that this is ductile. So what we have given? D, point D. This is now ultimate strength point. Ultimate strength point. E, this is now fracture point. This is now fracture point. So we can say that for X, D and E are close. It means brittle. And for Y, this D and E are far apart. It means that this is ductile. This is ductile. So we have what? Brittle, and this is not ductile, so our option is third. So our answer is third. The material X is brittle and material Y is ductile. And now question number 42. So in question number 41, we have to know about the stress strain curve, and then you just find that if the 2 points, the breaking point, the fracture point is also called the breaking point. With the breaking point and the ultimate strength point, or ultimate strength point means that the point where the elasticity is lost, and then after the, if stress is slightly increased, the length increases to a large amount, and in that case, if these 2 points are very close, it means that the given material is the brittle one, and if they are far apart, then they are not brittle but they are ductile. Now 42nd question. A body of mass M, a body of mass M is kept on a rough, horizontal surface, coefficient of friction mu, coefficient of friction equal to mu. A horizontal force is applied. A horizontal force is applied on the body, body, but it does not move. But it does not move. The resultant of normal reaction, the resultant of normal reaction, and the frictional force, force acting on the object, is given by F, where F is now option. First is, now this F magnitude is equal to mg, and second is F magnitude is equal to mg plus mu mg, and now third, this F is equal to mu mg, and now fourth is F is equal to mg into square root of 1 plus mu square. Now the solution. Now we are given the mass that is placed on the horizontal rough surface. This is now rough surface. This is the body kept here. Now on this, a frictional force will act in this direction. This is your Fr equal to mu n, and a horizontal force is applied. This is horizontal force. Now its normal reaction will be like this, and its weight will act vertically downward. Now then we are given here the frictional force, then this is the resultant. This is given in the question. The resultant of normal reaction and the frictional force. Normal reaction and the frictional force. That is the force F. This is the force F. So what we have? That we can do just it by taking it to like this. Then friction force, this is coming like this one. This is. So this is a right angle triangle. Just you will see. So this is suppose the point O. This is now point P. This is now point Q. So frictional force. Frictional force Fr is equal to mu n, and this is now mu or n is equal to mg. This is the two are equal, and the normal reaction normal reaction N equal to, this is Mg. So now, and the normal reaction, this is given Mg, so this is now right angle triangle. Resultant of normal reaction and frictional force Fr. Now you can see the right angle triangle in right angle triangle OPQ. So this OQ square is equal to OP square plus PQ square. And PQ, OP, this is given your this normal reaction. So normal reaction is your Mg plus this is PQ. PQ equal to Fr equal to mu Mg, and this OP equal to N equal to Mg. So this is mu Mg whole square, and this is now your F square. So now this F equal to square root of Mg square plus mu Mg square. So now you take the magnitude, then we will have this Mg into square root of 1 plus mu square. So our right answer is 4th. So what we are given that this is the force that is the resultant of the normal reaction and the frictional force, and this is given by this one. So our right option is 4th one. So this is now from the chapter of friction. And now question number 43. A particle of mass 5m mass 5m at rest suddenly breaks on its own into 3 fragments, The two fragments of mass m each move along mutually mutually perpendicular direction. Mutually perpendicular direction with speed v each. With speed v each, the energy released during the process, the energy released during the process is, now I have the options. First is 4 by 3 mv square. Third is 3 by 5 mv square. Third is 5 by 3 mv square, and fourth is 3 by 2 mv square. These are the options. Now here the situation is like this. This is a particle of mass 5 m. Now then it breaks into 3 pieces to move in mutually perpendicular direction. So when this breaks, then the 2 particles move in this direction. This is of mass m, this is of mass m. Then naturally the third will be moved in this direction. This is your mass 3m. Total is 5m, m and 3m. So now 5m. Now this is the velocity v. Velocity v. This is the velocity v. But the velocity of third one is not given here. So we can say that since initially this is at rest, so its kinetic energy is 0. Now then this breaks into the 3 pieces, then they move like this one, and now you can see that the third one will move in this direction. So this will in accordance with the law of conservation of momentum. So now you can see that these 2 particles, this is suppose the momentum is p, the relative momentum of the 2 small particles, and you can see that this is the right angle triangle. This p square equal to so much and this so much. Its momentum is m into v, its momentum is m into v. So now this p is equal to square root of mv whole square plus mv whole square. So this is mv root 2. This is now your p, and this momentum must be equal to the momentum of this particle. Let this particle moves with velocity v dash. So now velocity of this one. Let velocity of big particle is equal to v dash. So what we have? Applying law of conservation of momentum. this is your 3m into b dash equal to mb root 2. So this m and m will cancel, and from here we find that this b dash equal to b root 2 upon m. Initial kinetic energy. Initial kinetic energy E1 is equal to half into 5m. This is at rest. So this is 0. So now 0. And the final kinetic energy E2. This is the sum of the kinetic energy of the three particles. So this is now half m v square plus half m v square plus half. Now this mass is 3m. And this b dash equal to v root 2 upon m. No, this is not 3. So this is your v root 2 upon 3 whole square. So now you can have this E2 equal to half mv square plus half mv square equal to mv square plus this is now your 1 by 2 into 3m into this is now your v square into 2 upon 9. This is now this will cancel by 3, this 2 and 2 cancel. So this is now mv square upon 3. So what is left? mv square plus mv square upon 3. So this is equal to 4 mv square upon 3. So this is the final energy. This so much. It means that the energy released delta E is equal to E2 minus E1. So this is equal to 4 mv square upon 3 minus 0, or we can have this delta E equal to 4 by 3 mv square. So our right option is this one, 4 by 3 mv square. So our answer to this one is first. So this is now question number 43rd, and now I am going to 44. An object of mass 500 gram mass 500 gram. Initially at rest. Is acted upon by a variable force. Is acted upon by a variable force whose x component varies with x, whose x component varies with x in manner shown, in the manner shown, in the manner shown. The velocity of the particle at the velocity of the particle at x equal to 8 meter and x equal to 12 meter would have respectively respective values of nearly Now we are first given the here is this is now 0, this is your 10, this is 20, this is now force F, and here we are given the x, here is x, so this is 4, then this is now 5, then this is 8, this is your 10, and then this is given 12, so much. And here we are given that up to 5. This is like this, and then 8, this goes like this, then from 8 it is coming downward. Now then this is giving you 10, minus 10, this is your minus 20, this is giving you minus 25. So now then this 8, this is now 20, and then it goes to 10, and then after 10 this goes to so much, and then to so much. This is given. Here we will have this part is like this. And the options are, first option is your 18 meter per second, this is giving you 20.6 meter per second, and then 18 meter per second, 18 meter per second, 24.4, 24.4 meter per second. And now third is 23 meter per second. And 24.4 meter per second. And fourth is 23 meter per second, and this is now 20.6 meter per second. These are the options. Now what we have, this is the force, this is displacement, so the area of each segment will equal to the work done, and by using the theorem of work energy, we can have this work done is equal to the kinetic energy. So first we will find at x equal to 8 meter. Solution. Work energy theorem. This kinetic energy is equal to work done. This is the. So now for x equal to 8 meter, x equal to 8 up to this one, the area will be that this so much area and so much area, that must be equal to the kinetic energy. So this kinetic energy equal to, this is your 20 and this is now your 5 plus this is now your 10 into 3, so much. So this is given your half, and mass is given 1/2 kg. So 1/2 into mv square equal to, this is not 130, so much. So from here v equal to square root of 13/26 of 52, 520. And if you take the square root of this one, I think this will come out to be your 23 meter per second. It is now your 7, this is 23 meter per second. 23 meter per second. Approximate to so much. And now for x equal to 12 meter. Now then what you find, that this kinetic energy equal to, now this area plus this area. So this is now your 20 into 5 plus 10 into 3. This is now so much. Now this is being negative. And now you find from here, just from here, this so much, that this is given to be 2.5 here. If you find to this one, this is so much. So now we can divide this into two parts. So what we have, that the area of this so much plus area of this triangle, but this will be negative. So this is now 22.5. So either you do that, you find the area of this complete triangle. What we have? Minus, now this one. Now we are going in this part. This is complete is 25 into 2. 25 into 2. Then you subtract so much area. This so much, this is not triangle. That I can make it. This is now 2.5. This so much is this is your 1 by 2 into 1 into 2.5 minus 1 by 2 into 1 into 2.5 and then this so much is to be taken. So how we have to find this? First you find the area of this rectangle. This is not 25 into 2. 25 into 2. And then you subtract this area and this area. This is not triangular area. This so much is triangular area. This you subtract. This is what I have taken. This 1 by 2 into 1. This so much is 1. This so much is 1. This is equal to 1. This is your 2.5. So this is equal to your 100 plus 30 minus this is now your 50 minus this is your 2.5. So much is 2.5. And then one more is left here, this part, this one. So this is now your 10 into 2 plus 10 into 2. So plus 10 into 2 is now 20. So this is equal to 150 minus this so much is 47.5. So this is come out to be 0.5 so much. And this is again half mb square. M and this is now your b square. So what we find that this v equal to square root of this is now 4. So this is your 100 and this is now your 4. And after 1 to 410. So this is square root of 410. So this will be how much? It is approximately your 20.6 meter per second. This part is conversing because you have to think that these are the two parts. So these are the triangular part and this is to be taken 2.5. It means that this distance must be equal to how much? 2.5. This is 22.5. This is so much is 22.5. This is so much. Then you can find that this height is 2.5. So our right options must be what? 23 and 20.6. 23 and 20.6. This is now fourth one. So our answer is fourth. This question is somewhat conversing, somewhat typical because this part is only typical, remaining no difficulty. Now question number 45. A solid cylinder of mass 2 kg. A solid cylinder of mass 2 kg and radius 50 centimeter, rolls upon an inclined plane. Rolls upon an inclined plane of angle of inclination 30 degree. Of angle of inclination of 30 degree. The center of mass of the cylinder. The center of mass of cylinder has a speed of 4 meter per second. 4 meter per second. The distance traveled by cylinder on the inclined plane will be now options. Now this is given that g equal to 10 meter per second square. This is given to us. Now the options are, first is your 2.4 meter, second is 2.2 meter, and third is 1.6 meter, and fourth is 1.2 meter. Now the solution. Now this is given the inclined plane. This is the angle 30. Now from here the cylinder rolls on this one. So this is the cylinder. How to make it? This is cylinder and this goes on this one, and that it reaches up to, suppose the height is so much. This is now vertical height, suppose h, and this distance we have to find. So this distance is, suppose now x. Inclined plane at an angle of 30 degree with the horizontal, and now you can see that this will move till its final velocity is equal to 0. So either you use v square equal to u square plus 2s, or you can use the law of conservation of energy. So either way you can find it. law of conservation of energy. Half mv square into 1 plus k square upon r square equal to, this is now mgh. Since the cylinder is rolling, so it has both kind of motion, the translational and the rotational. So this m and n will cancel, and you are given that this half m is given to you 4 meter per second. So this is now square of 4 into 1 plus, for cylinder k square upon r square equal to 1. This is now your g, and this is now height. G is given to you 10 into h. So you can have this 1 by 2 into 16 into 3 by 2 equal to 10. And now h, this is now right angle triangle. So this is equal to the perpendicular upon hypotenuse, so this is sin 30. So this h equal to x sin 30. X sin 30. H equal to x sin 30. So now you can have the value 2 and 2 4. So this is now your 4, and this 2, this is now your 5. 2 3 is 6 equal to 5 into x into sin 30 1 by 2. So this is now your 12 upon 5. So this is now 2.4 meter. So our right choice is first one. So we have answer first. This is the correct answer. So just to apply the law of conservation of energy, and keep in mind that cylinder is rolling, so it has both the motions, translational and rotational. So total energy is equal to half mv square into 1 plus k square upon r square. This must be equal to mgh. Then just you calculate and find this value v, the x, that is 2.4 meter. So this is the complete question paper of Neet 2019 series H1. There are so many series, but in all the questions are the same. The sequence is being changed, and the sequence of the answer is also changed, so that no one could cheat. This is what one of the strategy made by the examination testing body, or by the testing body. So just you remember that all the questions in the physics are not just so much simple, but they are based upon your understanding and the concept, and if you know them well, only then you can find the correct answer. So remember that we have to keep in mind the facts of the physics. So just you calculate and then find the answer. Thank you very much.